Hi there, grade 10. So this is the first lesson of Unit 5. And I decided to actually start Unit 5 with a bit of a review first of grade 9, because I know some of our skills might be a little bit lacking from grade 9 because of COVID and you guys being out of school for such a big chunk of it. So I'm actually going to make this lesson just a review of solving equations. You would have done a big giant unit of solving equations in your second semester of grade 9 right before we left for COVID. I'm not quite sure if your teacher even got to finish it all or whatever. So I'm going to start this unit with this review here because you're going to have to be able to solve equations quite often for the rest of this unit and units to come. So here for the first question here, I have x minus 6 equals 10. All we have to do is isolate x. So I want to get rid essentially of that minus 6. Well, what's the opposite of minusing 6? It's adding 6. So if we add 6 to that side, those terms will cancel out, but we have to also be fair and add 6 to the other side. So the left-hand side is just x now all by itself equals 16, and we're done. Over here, same thing. I have 9 plus x equals 11. Now, many of you say, well, the answer is 2, obviously, because it's saying 9 plus what equals 11. The answer is 2, but if you wanted to kind of show me what you're canceling out, we would have to cancel out this 9 right here on the left-hand side. It currently is a positive 9, so to get rid of it, we'd have to minus 9. 9 take away 9 goes away. We have just that x left on the left-hand side, and you don't have to write that positive in front of it anymore. Because there's no other term on the left-hand side, we don't need that positive separating it from the 9. So it's just an x, and then 11 minus 9 is 2. So that's the fancy way of explaining how we get 2. Okay, now over here, we have a fraction, x over 4 equals 16. I want to isolate x. That's always my goal, is to isolate x, meaning get it all by itself. So right here, it's being divided by a 4. To get rid of a division by 4, we do the opposite of dividing, which is multiplying. So I would multiply this side by 4. And then what happens is, when you have a 4 up top and a 4 down low, they cancel each other out, right? Because I'll just write over here, what this is actually saying is, if I multiply this side by 4, I have 4x then divided by 4. Well, then what's 4 over 4? Well, just 1x, which is just the same as x. So the short way of doing it is just canceling out 4 over 4. But what we do to one side, we have to also do to the other side. So if I'm timesing the left side by 4, I have to also times the right side by 4. So on the right side, you're going 16 times 4, which is 64. Okay, for this one here, I have a couple things to get rid of. I have 2x plus 7 equals negative 7. My goal is to get this x here all by itself, right? I have two things to get rid of. I have a 2 to get rid of and a 7. You're going to leave the 2 and the x smushed together for as long as you can. We're going to take care of the 7 first. So to get rid of a plus 7, we have to minus 7 because that would cancel to 0. But what we do to one side, we have to also be fair and do to the other side. So I would only have 2x on the left, and on the right-hand side, negative 7, take away 7 more is now negative 14. Now, x isn't quite alone yet. We have to get that x all by itself, and it's being multiplied to that 2. So to undo multiplication is division. So if I divide by 2, those cancel, but what I do to one side, I have to also do to the other side, right? So I have x all by itself on the left, and then negative 14 divided by 2, negative 7. Done. Okay, this guy here, same type of idea. I have this 6.5 multiplied to that x. They're smushed together. That means multiplication. There's no symbol in between the two of them. That means multiplication. So I'm going to leave those guys to the bitter end together. So that means I'm going to have to get rid of this negative 5 first by adding 5 to both sides. So now I have negative 6.5x on the left-hand side. This went to 0, it's gone, equaling 14.5 plus 5 is 19.5. Now, these two guys are multiplied together, like I said, so to undo multiplication is division. You're going to divide by exactly what you want to get rid of. I want to get rid of a negative 6.5, so that x is all by itself. So I divide by negative 6.5 on both sides to be fair. Negative 6.5 divided by negative 6.5 cancels out, and then you just divide that on the right-hand side, and that equals negative 3. Okay, this one here, I like this example because it looks easy, but it's a bit complicated actually. So my goal is to get x all by itself. So right away I see that I can minus 3 off to both sides. So on the left-hand side now, if I minus 3 to both sides, on the left-hand side, I still have a negative x. So be careful there. That negative is glued to that x. But I canceled out the 3's, and then on the right-hand side, negative 6 minus 3 is negative 9. Now, you are not done here. You want your answer to look like this. X equals something, not negative x equals something. So what you can do to get rid of a negative is divide each side by negative 1, because the negatives will cancel out. So you'll just have x, and then negative 9 divided by negative 1, that symbol will just change. It'll become a positive 9. Okay? So you can't have a negative x in your answer. It has to be x. All right, we're getting a little bit more complicated here because with these guys, we have variables on both sides. As you can see here, I have x's here and x's here. So your goal is to get all the x's on one side and all the numbers on the other. So I'm going to get my x's all on the left side. I like keeping my x's on the left side. So if I want my x's on the left side only, I'm going to cancel out the x on the right-hand side. So by going 4x minus 4x, that becomes 0. But I have to also be fair and minus 4x to the left side too. So now what I have is 2 minus 4 is now negative 2x. I still have the plus 5. Equals, this has gone to 0, and then on the right-hand side, all I have is 7. Now, it kind of looks like a question we were just looking at. I want to get this x by itself, so the first thing I'm going to do is minus 5 to both sides, so that I have negative 2x, that's gone, equals 7 minus 5 is 2. Now, those two guys are multiplied together. I get so many students here who are tempted just to add 2 to both sides. But you have to realize that that's a multiplication of 2. These guys are multiplied together. So to undo a multiplication, we divide by exactly what we want to cancel out. So I'm going to divide by negative 2. So then I have x equaling 2 divided by negative 2 is negative 1. All right. This guy here, the first thing I'm going to do is simplify, because I have a bunch of x's on the right-hand side, and I can just, so I'm going to read this as negative 4 minus 7x equals just 3x now. 5 minus 2, right? Okay, so now this question looks similar to the one we just did. I have an x on either side. I like keeping my x's on the left-hand side, so I'm going to get rid of the x on the right-hand side by minusing 3 x's to both sides. So now if I rewrite this, I still have negative 4. Negative 7 minus 3 is now negative 10x equals, those went away to 0. 3 minus 3 is 0, right? Equals 3. Okay, so now the 10 and the x are multiplied together. We're going to leave them be till the very end. So that means I'm going to get rid of this negative 4. So if I want to get rid of a negative 4, I'm going to add 4. So you always just do the opposite symbol. Negative 4 plus 4 is now 0. So my left-hand side is just negative 10x equals 3 plus 4 is 7. Now, again, those are multiplied together. So to undo a multiplication, we do division. So those cancel out. I have only x left on the left-hand side. And then 7 over 10, it can't divide, right? It can't reduce. So we're just going to leave it as a negative 7 over 10. So sometimes your answer will be a fraction, and that's okay. All right. This guy here, I'm including brackets now. So distribution is in here. So distribution means whenever you have a number outside of the bracket, you multiply it in. And that should ring a bell from Unit 3 when we did a bunch of multiplying. So if I bring that 2 in, I'm going to get 2x plus 10. Then if I bring the 6 in, I'm going to get positive 6x minus 30. And then there's nothing to do on this right-hand side. Now I'm going to simplify it because on the left-hand side, I have a whole bunch of stuff going on. I can simplify those two guys together, right? And I can simplify those two numbers together. So if I rewrite this, 2x plus 6x is actually 8x. And then 10 minus 30 is actually negative 20. And my right-hand side didn't change. Now I'm going to cancel out the variable on the right-hand side. I don't like having x's on both sides, so I'm going to take that whole x away by going minus 5x, but I have to be fair and do it to both sides. Now I'm going to do something extra here. So I know now that I'm going to have x's only on my left-hand side, because that's going to be 3x, right? I know I'm going to eventually have to add to get the 20 over to the right-hand side so that there's no numbers on the left-hand side. So I'm going to do both of that in the same step. So I minus 5x to both sides, but then I added 20 so that all of my numbers, my constant terms, are just on the right-hand side. Then I'm going to divide by 3. So I get x all by itself equals 21 divided by 3, which is 7. Okay, this guy here, you have square brackets and round brackets. So you can see you have a big square bracket here, and then on the inside you also have that little bracket. We're going to take care of that little bracket on the inside first. You always try to simplify brackets as much as possible. So you do not go 3 plus 2, you guys. That's not the order of operations we know to follow. We have to do multiplication first. And so this 2 is being multiplied to those two guys. So it's actually 3 plus 2x plus 10, close the bracket, equals 76. Now, in the bracket, I'm going to clean that up because it's actually just 2x plus 13, right? 10 plus 3. And now I have another distribution to do. That 4 gets sent in and becomes 8x plus 4 times 13 is 52 equals 76. I only have an x on one side, so right away I'm just going to get rid of that 52. Okay, so 76 minus 52 is 24. So I have 8x on the left-hand side equaling 24 on the right. I divide off that 8, so those cancel, and I get x equaling 24 divided by 8, which is 3. Okay, fractions. This is where it gets a little bit more complicated. So in these two questions here, the two I'm going to start with here. In the first one, you have two fractions, right? You have a denominator of 4 and a denominator of 2. Whenever you have multiple fractions, you're going to find the common denominator, which here is 4. If I multiply each term by 4, something awesome happens. We get rid of all of the fractions in one shot, because here a 4 up top and a 4 down low cancel each other out. So I just have 3x on the left-hand side. But on the right-hand side, you have to be careful because this is actually now 28 over 2, right? 4 times 7 is 28 and still divided by 2, which is just a big fat 14. So by multiplying each side by the common denominator, it actually cancels out the fraction completely. Then we divide by 3 to cancel out those 3's there. X is all by itself, and 14 over 3 doesn't reduce, so we're done. Okay, over here, I have to isolate that guy, right? It's on the right-hand side. I don't like that, but we'll survive. I don't have any other x's, so I just have to deal with it on the right-hand side. I'm going to get rid of this 4 right away so that it looks like this. Negative 12, right? Negative 8 take away 4 equals, that's gone, x over 3. So just by minusing off that 4, I've already cleaned up the question quite a bit. Now, this question here, if we scroll up, actually looks like one of the first ones we did. If I can zoom in again, whoops, holy smokes. It looks like this guy right here. We just have one fraction equaling a big fat number. All we did here was multiply each side by the denominator, because technically that is the common denominator. 3 is the common denominator. It's the only denominator. So we multiply both sides by 3, right? So on the left-hand side, that's negative 36 equals cancel. And we're done. And I just have my x on my right-hand side. That's fine. You can flip them around. Same thing. Okay. This guy here is where you really have to put your listening ears on. And also, sorry, that should not be an x and an m. My bad. That should be an x. Sorry. Okay. So again, you have multiple fractions here that have different denominators. You're going to find your common denominator between 3 and 2 is 6. And what you do is you multiply each fraction or each term by that 6. So this is one big fraction right here, so it gets one big 6, and one big fraction right here gets another big 6. So this is where you really have to start paying attention if you weren't paying attention. All right. You have a 6 up top and a 3 down low. Let's just ignore that 4x minus 3 for a second. Pretend it's not even there. Ignore that for a second. What's 6 over 3? Or what does 6 over 3 simplify to? Well, 6 divided by 3 is 2. So what happens is a 6 over 3 actually just becomes a 2. Okay? Now this is where it's important to really listen. This 2 that's left over is being multiplied to both of those terms right there. That 2 gets multiplied to both the 4 and the 3. So that's why I just put brackets around it to kind of remind ourselves we actually have to distribute that 2 into both terms. The same thing happens here. 6 on top, 2 on the bottom. We're going to ignore that for a second. What's 6 divided by 2? 3. Okay, so, sorry, I'm going to change this to x again. 6 over 2 becomes a 3. And that 3 will be multiplied to both terms in that bracket. So this is what we get. I have 2 now multiplied to 4x minus 3 equaling 3 being multiplied to the 3 plus x. And now we distribute. 2 times 4x is 8x, 2 times 3 is negative 6. 3 times 3 is 9, plus 3 times x is 3x. Whoops, sorry. Okay, I have x's on both sides. You know me, I like keeping my x's only on the left, so I'm going to cancel out my x on the right by minusing 3x to both sides. But also in the same breath, I know I'm going to have to add that 6 to both sides right away, so I'm going to do that in the same step. So on the left-hand side, 8x minus 3x is 5x. I already added the 6, so that's already gone, equaling, and then on the right-hand side, 9 plus 6 is 15, and those 3's already canceled. Divide off the 5, divide off the 5, cancel, x equals 3. Okay, I know that was a little complicated, so I kind of chose one more similar to that. That's this guy right here. Okay, common denominator. We have a bunch of fractions. Common denominator between 6, 9, and 4. So what I do is I choose the bigger number, and I just kind of list the multiples of 9 in my head until I find one, until I find what I know all those numbers can go into. So 9, well, 6 can't go into 9. 18, well, 4 can't go into 18. 27, no, 4 can't go into 27, neither can 6. The next one, 36. There it is. Because 6 can go into 36, 4 can go into 36, and 9 can also go into 36. So I'm going to be multiplying every term by 36. And now we start doing the dividing part like we did before. So 36 over 6 becomes a 6. 36 divided by 6 is 6. So we can't forget that that 6 is still here and it'll be multiplied to those guys. So my first term becomes 6, and then in brackets x plus 5. Okay, this is where you have to really pay attention. 36 divided by 4 is 9. And that 9 is going to be multiplied into both of those terms. But watch, you don't miss out on that negative. It's a negative in between those two brackets, then the 9, then the x plus 3 in brackets. Over here, 36 divided by 9 is 4, so that 4 is multiplied into both of those terms, x minus 1. So that's what we get. So by multiplying every term by 36, boom, all the fractions are gone, and we start distributing. 6x plus 30, be careful, the negative 9 gets sent in, so negative 9x minus 27 equals 4x minus 4. Now on this left-hand side, I'm going to simplify. 6x minus 9x is negative 3x. 30 minus 27 is still a positive 3. On the right-hand side, there's not much I can do. Now, I don't like having x's on the right-hand side, so I'm going to cancel those out by minusing 4x to both sides. But then I know eventually I'm going to have to minus this 3 off anyway. Might as well do it now to both sides. So on the left-hand side, negative 3x minus 4x is now negative 7x. That went to 0 equals 4x minus 4x went to 0. Negative 4 take away 3 is negative 7. Divide off the negative 7 because you want to cancel that out. And you get x all alone on the left equaling negative 7 divided by negative 7, 1. Okay, so I hope that that was more or less a review of grade 9 and some of that stuff sounded familiar. Okay, the assignment is down here for those of you who haven't been to class lately and haven't had a chance to pick up hard copies of assignments, but I will give this to you guys when I see you next in class. Okay. Good luck.